Welcome back. In the last lecture session, we have learned about the procedure to be followed for binary search algorithm. These are the first 5 steps. Next, 6, 7, 8. In totally, there are 9 different steps which are to be followed. I explained it with an example. This was an example with a key number 31 and the list is given here, an arranged list. How to search for the given key. In this class, I will write a Python program by using Anaconda interpreter and let us see what is the result and how it works. I have written here a method or a function. This is my function def. It defines the function. I call my function as bsearch, a binary search, which takes 1, 2, 3, 4 parameters. First one is L, which is the length of the list. The list itself. L is the list and E is the search element. I want to check whether E is present in the given list L or not. And the third parameter is the low, which is nothing but the first address, the very first index of the list, and high is the last index. I repeat, bsearch function requires 4 parameters. The first parameter is the list and the second parameter is the search element. Third parameter is the lowest index of the list and the fourth parameter is the highest index of the list. Now I will directly go to the main program. This is my main program. I have defined a list here. L equals the whole thing is enclosed inside square bracket since it is a list. My elements are 10, 14, 19, 26, 27, 31, 33, 35, 42 and 44. For binary search, it must be an arranged list. It is arranged in ascending order so that I can go through iteratively from one step to another step. You can see here the same example I have taken, which I have explained in the earlier class: 10, 14, 19, 26, 27, 31, 33, 35, 42 and 44. Next, you call the method bsearch, pass L, 31, 0 and 9. You see here, what is L? Parameter L is the list. The whole list is to be passed as the first parameter. What is the second parameter? It is 31. My search key is 31. Here in the function, the actual parameter is E. So the E is the formal parameter. Actual parameter is 31, which will be assigned to E. Next is the low index of the list. So the first element, address of the very first element is the lower index, whose address is 0. As you know, totally there are 9 elements. The address here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the highest index of the given list. Okay, so we have passed all 4 parameters. First one is the list, second one is the search element, and third one is the lower index, and the last one is the higher index. Then when it goes to this function bsearch, it will return a Boolean value which is either true or false. If my function returns a true value, true Boolean value, that means if the key which I want to search is present in the given list, then display a message, given element is present in the list. Otherwise, if my function returns a false value, it just skips the if statement, goes to else, and it prints print given element is not present in the list. This is my main program. In the main program, what I am doing, I have defined a list. Then I am calling bsearch function by passing 4 parameters along with the if statement. if my B search function returns a true value, it indicates the search key is present in the list. Otherwise, it is not present in the list and an appropriate message will be displayed. Now, coming to the very important part, which is the function, B search function. This B search function is used to implement binary search algorithm. Now, the first statement here is if high equals low. High means the index of the last element, the first element is equal to the index of the last element. That indicates what? It is a list having only one number. So if the number of elements in the list is only one, then only the high index will be equal to low index. If it is equal to 0, then it enters the if in the indentation of the if loop, if body. If the list element at the low index is equal to E is the search key. If the element at the low index, which is same as the high index, is equal to the element which is to be searched, then it returns a true value. So it will return a true value if the element at low is equal to the search element E. It will directly come here. If high is not equal to low, then it indicates the number of elements in the list is more than 1. Then it goes to the mid. It skips the if statement and comes here so that it will choose either the left sublist or the right sublist. To find out the mid value of the list, the mid index of the list, what I am doing? I am using an integer division operation, / low plus high /2. What this statement does? Low value is equal to 0 and high value equal to 9. 0 plus 9 equal to 9. Do an integer division. 9 divided by 2 is equal to 4.5. Since it is an integer division, it truncates whatever is present after the decimal point. The result of this one is 4. Hence, the value after this integer division, 9 divided by 2 is equal to 4, will be assigned to mid. You can see here. So the mid value is this one, which is equal to 0 plus 9 divided by 2, which is equal to 4. At 4, what we have? At index 4, I have an element whose value is 27. Let me continue. Now, my index is the new value, which is the fourth element of the list, index with address 4. If the element at fourth index, which is the mid element, is equal to E is the search key, then you return true. That means the number which I am searching is present at the mid position at 4, hence you return it. Otherwise, you use an else if statement here. Why do we need else if statement? Because if the element is not present exactly at the mid position, then I have to choose either the left sublist or the right sublist. If the element at the mid position, the value of that element is at the mid position, is greater than the search key, then what I have to do? So there is nothing to left, you return false. If it is greater than E, I have to choose either the left sublist or the right sublist. Okay, so now if it is equal, you return a true, otherwise return a false. Else, after else if, it will come here by taking a new value. So this is my left sublist. If the list mid value is greater than E, it goes to the left sublist. You see here. So in the left sublist, I have to create new index values. In the sense, if it chooses the left sublist, it comes here. 0 is the new starting address and 3 is the ending address, low value and high value. which must be assigned accordingly. That's what I am doing here. I am again calling B search. It is in a sort of recursive procedure, recursive function. A function calls itself. L is the list. There is no change there. E is the element. Again, there is no change. Now, low value also does not change. It's same. It is 0. Only high value changes for the left sublist. It is mid value minus 1. What is the current mid value? It is 4. 4 minus 1 is the 3. So it will go back and again searches the left sublist. Yeah, otherwise, if this elif is false, if the value at the mid position is less than E, then it comes to this else. What it does? It will call the right sublist. It will search for the right sublist. For the right sublist, again, L remains same, E remains same, and high value remains same, which is the last element at position number 9. Only the starting value, the lower index will change. It is mid plus 1. You see here. Mid value is 4, mid plus 1 is 5. So in my example, which I have taken here, the right sublist will be chosen because my search key is 31, which is greater than 27, which is the mid value. Okay, so it goes to the right sublist and it calls the iterative procedure here, the recursive B search program method with a new value of mid plus 1, the low value, high remains same. The whole operation is performed. Again, the right sublist will be further divided into two to choose right sublist. And this operation will be repeated till it finds only one element or two elements in the list. If that happens, it will come out of the very first if statement, whether it is true or false, then displays message accordingly. So this is about the implementation of binary search algorithm by using the same steps that we have seen in the procedures, the steps to be followed for implementing binary search. Let me run this program and see what is the output. So here my search key is 31. So 31 is present here. It should display given element is present in the list. Okay, this is my output. Given element is present in the list. Now you choose another number which is not present in the list. Say I will give 18. 18 is not present in the list. If I run this program, it says given element is not present in the list. Though binary search is complex when compared to linear search, algorithmically complex, but the time taken to produce the result is independent of the position where the element is present. So it is similar to successive approximation ADC where conversion time is almost constant. So here also it goes to the middle one, next middle one, next middle one, then displays the result. In the next class, so we will discuss about some of the sorting algorithms. Thank you.